No problem. Hello students, so this is your chemistry mentor Dr. Reddy. So in the last class we discussed about the complex compounds. So in that we already discussed about the classification of ligands. So in the last class we discussed about the monodentate neutral ligands as well as monodentate positive ligands. So now this is the monodentate negative ligands. So in the monodentate negative ligands, these are the ligands. Ligand, this is the name of the ligand. So name of the ligand, and this is the name of the ligand. This is the donor atom, and the charge of the ligand it is. There are 4 columns there now. So in the first one it is hydrido. H minus is the hydrido. Donor atom is the hydrogen, and charge is -1. And this is the hydroxo. So donor atom is this oxygen, and charge is -1. This is thiohydroxo. So it is also monodentate negative. So donor atom is the sulfur, charge is -1. This is cyano. Cyano is the Cn minus. So on this Cn minus, this carbon is the donor site. This carbon is the donor site. So on nitrogen we have the negative charge, even though this carbon is donating an electron pair to the central atom. That's why the donor atom is the carbon. And charge on the ligand is the -1. This is isocyano. So in this isocyano, nitrogen is the donor atom. Even though on carbon we have the negative charge, this nitrogen is donating an electron pair to the central atom. That's why it is acting as a ligand. So this name is isocyano. So donor atom is the nitrogen, charge is -1. This is isocyaneto. This is cyaneto. Cyaneto is the name of that ligand, O minus C triple bond N. And here oxygen is the donor atom, and charge on the ligand it is -1. This is cyaneto. Next is isocyaneto is the O minus N triple bond C. This is the isocyaneto. Isocyaneto is ONC. This is isocyaneto. So in this nitrogen is donating electron. Nitrogen is the donor atom, and charge on the isocyaneto is the -1. Next, this is the SC triple bond N. So on this sulfur is the -1. So S minus C triple bond N. This S minus C triple bond N is the thiocyaneto. This is thiocyaneto. Thiocyaneto. So donor atom is the sulfur. This sulfur is donating electron pair to the central atom. This sulfur is the donor atom in this case. Therefore sulfur is the donor atom, and charge on the ligand it is -1. And isothiocyaneto. So what is meant by isothiocyaneto? Isothiocyaneto, it is the reverse of this one. So now you write this one N triple bond C S minus. This nitrogen is donating a electron pair. This nitrogen is the donor atom. Therefore nitrogen is the donor atom, and charge on the ligand it is negative. Therefore all these are under what now? Monodentate negative ligands. This is the nitrogen is the donor atom. Here sulfur is the donor atom. In this oxygen is the donor atom. In this also oxygen is the donor atom. This is the nitrogen is the donor atom in case of isocyano, but this is the carbon is the donor atom in case of cyano. So these are the some important monodentate negative ligands. Monodentate negative ligands. So after this again we have some more monodentate negative ligands. So monodentate negative ligands, for example, NH2 minus. This is the amido. The name of this ligand it is the amido. So name of the ligand it is amido. So donor atom is the nitrogen in this case. Donor atom is the nitrogen, and charge on the ligand it is -1. So this is NH2 minus. So NH minus 2 is the imido. Imido is the NH minus 2. So in this also again nitrogen is the donor atom and charge is -1. And N minus 3, this is the nitrido. Nitrido is the N minus 3 and here nitrogen is again donor atom and charge is -1, and then this is the nitrido and this is N3 minus, this is the azido. So here also nitrogen is the donor atom and this is the charge is on the N3 minus is the 1, that is the monodentate negative ligand, and NO2 minus, this is the nitro. Here also nitrogen is the donor atom and -1 is the charge of the ligand, and ONO, this is the nitrito. This is the nitrito ligand. Here the oxygen is the donor atom. This oxygen is donating electron pair to the central atom. That's why oxygen is the donor atom. Here also -1 is the charge, and NO3 minus. This is the nitrato. Here nitrogen is the donor atom and -1 is the charge. And these are the some important monodentate negative ligands. In addition to this, we have O2 minus 2. So O2 minus 2, this is the O2 minus 2, it is the peroxo. O2 minus 2 is the peroxo. So in this oxygen is the donor atom and it is the monodentate negative ligand, and O2 minus, this is superoxo. So here also oxygen is the donor atom and this is the monodentate negative, and O2, this is O minus 2. O minus 2 is the this is the oxido. This is oxido. So here oxygen is the donor atom and this is also monodentate negative ligand. So all these are under monodentate negative ligand. So all these will under what now? Monodentate negative ligand. So NH2 minus is the amido, NH minus is the imido, N minus 3 nitrido, N3 minus is the azido, NO2 minus is the nitro, O minus N double bond O nitrito, NO3 minus nitrato, O2 minus 2, this is the peroxo, similar to H2O2. This is O2 minus KO2, that is the superoxo, potassium superoxide KO2, and O minus 2 is the looking like what now? H2O, water, hydrogen oxide. This is O minus 2, therefore oxido, oxygen the donor atom, and charge on the ligand it is the -1. And after this one more, that is bidentate neutral ligands. Bidentate neutral ligands. So number of donor atoms are 2 in this case. Number of donor atoms are in this case is 2 na. So the first it is ligand na. So ligand it is ligand ethylene diamine. So NH2 so NH2 CH2 NH2. This is ethylene diamine. So CH2 is the ethylene. So we have 2 nitrogens, therefore this is ethylene diamine. So the abbreviation used in the complex compounds with the EN. So here this is the nitrogen is the donor site, and this is also the another nitrogen is the another donor atom. So bidentate means 2 donor atoms. So ligands with 2 donor atoms will comes under this classification. So this is the nitrogen is the 1 donor atom, this is the another nitrogen is the another donor atom. Therefore nitrogen and nitrogen, both the donor atoms are the 2 nitrogen atoms. Charge on the ligand it is the 0. So charge, these are the neutral ligands, these are the donor atoms. There are 2 donor atoms, nitrogen. This is the name of the ligand, it is name of the ligand ethylene diamine. And the next it is propylene diamine. So CH3 propylene, CH NH2, and this is the CH2 NH2. This is the propylene diamine. So propylene diamine. So propylene diamine, it will be abbreviated by PN. So donor atoms, this is the one donor atom in this case, this is the another donor atom. So both are the donor atoms, therefore nitrogen and nitrogen. Both the donor atoms are nitrogens only. And this is the chargeless species, therefore this will under neutral. And another one, this is the CH2NH2, and this is the CHNH2, and this is also CH2NH2. So this is 1, 2, 3. This is the trimethylene triamine. Trimethylene, suppose this is the, so trimethylene diamine, this is trimethylene diamine. Trimethylene, so methyl groups, methylene groups are 3. This is the methylene, this is also methylene, this is also methylene. Therefore there are 3 methylenes. Therefore trimethylene diamine. So diamine means it is a bidentate. So this is the one donor atom, this is the another one donor atom. Therefore both the donor atoms are nitrogens, and this is also chargeless species, therefore comes under neutral ligands. So this is ethylene diamine, this is propylene diamine, this is trimethylene diamine. And next it is the this one. So dimethyl glyoxime. This is the most important ligand now, dimethyl glyoxime. Dimethyl glyoxime, this is this will be abbreviated by DMG. So dimethyl glyoxime. So CH3 glyoxime, CH3 CH3 double bond NOH. So double bond NOH. So this is the dimethyl glyoxime. This is the one donor atom, this is also another one donor atom. So this will be neutral because there is no charge on the dimethyl glyoxime, therefore this will comes under neutral in charge. Therefore charge is 0, and this is the DMG, and both the donor atoms are the nitrogen and nitrogen. So nitrogen and nitrogen, both are the donor atoms are nitrogen and nitrogen. So next it is after this dimethyl glyoxime bipyridyl. This is the one pyridine, and this is the another one pyridine molecule. Both will be joined at these places now. So this is the bipyridyl, BIPY, and this is the one donor atom, this is the another one donor atom now. So therefore this will also comes under neutral ligand because no charge on the species, and donor atoms are nitrogen and nitrogen. And one more, this is hydrazine. So NH2, this is the hydrazine. So in hydrazine also, hydrazine means NH2 single bond NH2. So this is the one nitrogen having one electron pair, this is the another nitrogen is having another electron pair now. So this will also donate electron pair, this will also donate electron pair to the central atom. That's why both are the donor atoms, therefore N and N. So there are two donor atoms in this case now. Therefore these are the bidentate neutral ligands. These are bidentate neutral ligands. So one is ethylene diamine, it is the ethylene diamine, this is the propylene diamine, this is the propylene diamine, or what now this one 1,2 diaminopropane. The IUPAC of this one, it is the 1,2 diaminopropane. This is 1,3 diaminopropane. Suppose this is the 1, this is the 3. So 1,3 diaminopropane or trimethylene diamine. This is the glyoxime, dimethyl glyoxime, abbreviated by DMG, and this is the bipyridyl or bipyridine, BIPY, and this is the hydrazine. So both are all these are under what now, bidentate neutral ligands now. So after this we have the bidentate negative ligands. Bidentate negative ligands. Bidentate negative ligands. So what are bidentate negative ligands now? So ligands with two donor atoms with negative charge. So first is ligands, name of the ligands, and donor atoms and charge. So this is negative, that's why what now this one, all these are having what now charge. So what are the first it is the carbonato minus 2. So CO3 minus 2. So CO3 minus 1, this is also minus 1. So this is the donor atom, this is the donor atom, this is also another donor atom now. Therefore there are two donor sites in this case now. So both are under what now? Both are oxygen and oxygen. Oxygen and oxygen are the donor sites. Charge is negative by minus 2. After this sulfato also minus 2. So S double bond O, this is the double bond O minus, this is also O minus. So how many number of donor atoms now? This is the donor atom, this is also another one donor atom. So therefore it is bidentate with negative charge. Therefore both the donor atoms are oxygen and oxygen, minus 2 is the charge. Next oxalato, it is also minus 2. Oxalato means C double bond O minus, this is the C double bond O minus, C2O4 minus 2. This is what now? C2O4 minus 2 is the oxalato. So abbreviation used in the complex compound is the OX. Abbreviation used in the complex compound is the OX. So this is the donor atom and it is also donor atom now. Therefore donor atoms are what now? Oxygen and oxygen, and charge is what now? Minus 2 charge. And then glycinato. So what is glycinato? Glycinato is the minus 1. Suppose glycine NH2 CH2 C double bond O minus. This is the glycinato. Glycine is what now? NH2 CH2 COOH is the glycine. And here this is the one donor atom and this is the another one donor atom now. Therefore this is also under what now? Bidentate negative ligand, and here this is the one donor, this is the oxygen. So nitrogen and oxygen. So nitrogen and oxygen both are the donor sites. Negative it is the minus 1. So charge on the ligand it is the minus 1 only. And dimethyl glyoxynato. So it is very very important. Dimethyl glyoxynato minus 1. So what is the NH2? So CH3 so dimethyl glyoxime. So CH3 C CH3 double bond NOH. This is the double bond NO minus. So this is having what now? One negative charge. Therefore simply dimethyl glyoxynato minus 1. But what are the? This is the nitrogen is the donor site, and in this case oxygen is the donor site now. So there are two donor sites. One is at nitrogen and another is at oxygen. Therefore this is also bidentate with one negative charge now. So these are the important bidentate negative ligands. And one more, that is acetyl acetonato. Acetyl acetonato. This is also minus 1. So acetyl acetonato is also minus 1. So what is the acetyl acetonato? So CH3 C double bond O. This is CH3 C O minus double bond CH CO CH3. So this is the acetyl acetonato. This is what now? This one acetyl acetonato. So this is the acetyl acetonato. So abbreviation used in the complex compound, it is ACAC. AC is the abbreviation used in the complex compound IUPAC name. So CH3CO minus double bond CH, single bond C, double bond O, CH3. This is acetyl esterato having how many charges now? Only -1 charge. Therefore, this is the one donor atom and this is also another one donor atom. Therefore, both are what now? Oxygen and oxygen. So both the donor atoms are what now? Oxygen and oxygen, but negative charge is -1 only. So these are the important bidentate negative ligands. So we already completed the bidentate neutral ligand. This is the bidentate what now? This is bidentate negative ligand. So carbonato, sulfato, oxalato, glycinato, dimethyl glyoxynato, acetyl esterato. So acetyl esterato is the abbreviation used in the complex compound is the ASAC, ACAC. This is dimethyl glyoxynato, abbreviation used in the complex compound, it is the HDMG. This is what now? This is DMG. DMG is the abbreviation used in the complex compound, it is the DMG. DMG is the complex compound used in the complex compound. Whereas in the case of this one, this is the HDMG. So this is HDMG. HDMG is the abbreviation used in the complex compound. It is the HDMG because here hydrogens attaching for the two oxygens, whereas in this case one hydrogen is less. In case of dimethyl glyoxynato, one hydrogen is less than the dimethyl glyoxime. That is dimethyl glyoxime. This is dimethyl glyoxynato. This is monodentate. This is bidentate negative. That is the neutral ligand. And then so after this tridentate neutral ligands. Tridentate neutral ligands. Tridentate neutral ligands. So what are the tridentate neutral ligands? So first it is diene. So dimethylene triamine. So CH2, CH2. This is the CH2. This is NH2. So again NH and CH2 taken twice. This is the NH2. So this is CH2 taken 2 times means 1 ethylene. This is also ethylene. So diethylene, this is the donor atom. This is the nitrogen is the donor atom. This is the nitrogen is the donor atom, and this is the nitrogen is the donor atom. So there are how many donor atoms now? There are 3 donor atoms. Therefore, this is the tridentate. Tridentate. Therefore, it is what? Tridentate neutral. Is there any charge on this now? Therefore, number of donor atoms are the name of this one. It is what? Trimethylene. 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 Dimethylene. So this is dimethylene. So dimethylene triamine. Dimethylene triamine. This is diene is the abbreviation used in the complex compound. So donor atoms are how many donor atoms now? 3 donor atoms. So N, N, N. So there are 3 donors. This is the one, this is the one, this is the one. Therefore, and charge, it is neutral in charge. So this is the charge. And these are the donor atoms. Donor atoms, 3 are nitrogens. Here it is what? This is the name of the ligand. It is name of the ligand. It is diene. Name of the ligand, it is diene. So this is what now this one? This is tridentate neutral ligand. So after this we have one more now. That one what will be the tridentate neutral ligands? NH2 CH2 taken twice, NH CH2 taken twice, NH2. So this is the tridentate neutral ligand now. And then tridentate negative ligand. So what will be the tridentate negative ligand now? So tridentate negative ligand. That is the neutral ligand, and this is the tridentate negative ligand. For example, this is NH CH2 COO minus This is CH2COO minus. What now this one? What is the name of this one now? This is tridentate. This is the O minus is the one donor atom. This is the one donor atom. This is the another one donor atom, and this is the one donor atom. So this is, it will be what now? NH minus 2. NH. This is imidodiacetato. Imidodiacetato. The name of this one, it is what now? Imidodiacetato. Imidodiacetato. What will be the charge now? Minus 2. So IDA minus 2, this one. IDA minus 2. So donor atoms, this is the one donor, and this is also another donor, and this is also another one donor now. So this is the donor, this is the one donor, this is the oxygen is the another donor, this oxygen is also another donor now. Therefore there are 3 donor atoms, therefore this will under what now? Tridentate neutral. So one nitrogen and one oxygen, and another is the oxygen. So charge on this what now? Minus 2 is the charge. So IDA minus 2, imidodiacetato. So this is the tridentate negative, this is a tridentate neutral ligand. And one more, so after this tetradentate negative ligand. Tetradentate negative ligand. So what are the tetradentate negative ligands? For example, this is the N. On nitrogen we have the one lone pair, and this is the CH2COO minus, this is CH2COO minus, and this is the CH2COO minus. So what is the name of this one now? This is NTA minus 3. So what is nitrido? NTA minus 3. Nitrido triacetato. NTA minus 3. So nitrito or nitrido triacetato. Nitrito triacetato is the name of this ligand. So here how many donor atoms? This oxygen is the one donor, this oxygen is another donor, this oxygen is another donor, this nitrogen is another donor. Now there are 4 donor atoms in this case now. Therefore what now? One is 3 oxygens, oxygen and nitrogen. So there are 4 donor atoms. This one. So there are 4 donor atoms now. So charge on this one, it is the minus 3 charge. This is the tetradentate negative ligand. This is the tridentate neutral. Diene is the tridentate neutral now. So triene is also what now? That one. So triene is also trimethylene tetraamine. That is also tetradentate neutral ligand now. So what about the? So before this. This one is what now? For under the tetradentate. So tetradentate neutral. One of the important ligand na this one. What now? That one tetradentate neutral is the triene. So the name of this one, it is triene. Triene means trimethylene tetraamine. So trimethylene, you write trimethylenes, 3 methylene groups. 3 methylene groups. These are the 3 methylene groups. Each one is connecting to what now? NH2. This is NH, and this is also NH, and this is also NH2. So how many donor atoms in this case now? This is the one donor atom, because of there is a lone pair electron on this nitrogen. Here also one electron pair on this nitrogen. Therefore it is also one of the donor site. And this is also one more nitrogen. It is also donor site. This is also nitrogen, and this also acting as a donor site. Therefore this is a tetradentate neutral. Is there any charge on this now? So what is the name of this one now? This one is triene. Triene means trimethylene. So trimethylene tetraamine. Tetraamine is the tetradentate neutral ligand. Is there any charge now? So what are the donor sites now? 4 nitrogens. So these are there are 4 nitrogens, each donating an electron pair, each donating an electron pair to the central atom. That's why the number of donor sites are 4. They are nitrogen, and charge on this one, it is what now? 0. It is a neutral ligand now. So coming to the tetradentate negative, this is the nitrido triacetato. This is the tridentate, but this is the tetradentate neutral. This is the tetradentate negative. This is tetradentate negative. This is the tetradentate neutral ligand. There are 4 donor atoms. In this negative is there. That's why this will under what na negative tetradentate negative ligand. So after this pentadentate neutral ligands. Pentadentate neutral ligands. So what are the pentadentate neutral ligands? So hexamethylene pentamine. Suppose CH2, this is the methylene, this is also methylene, hexamethylene. So hexamethylene. So how many methylene groups now? 1, 2, 3, 4, 5. This is the CH2 taken twice. So there are 6 methylene groups. Each is connecting to NH2. This also NH. This is connecting to 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 NH. And this is connecting to NH2. So 1, 2, 3, 4, 5, 6, 7. So you reduce one now. So this is NH2. So 1, 2, 3, 4, 5, 6. There are 1, 2, 3, 4, 5. 5 only you write now. So this is what now? NH2. This is NH2. So 1, 2, 3, 4, 5. Therefore it is a pentadentate. 1, 2, 3, 4. Tetramethylene pentamine. 1, 2, 3, 4, 5. So what is the name of this one now? 1, 2, 3, 4. Tetramethylene. So tetramethylene. 1, 2, 3, 4, 5. Pentamine. So this is the name of the pentadentate neutral ligand. Pentadentate neutral ligand. So there are this is the donor site. This is the donor site. This is the nitrogen having 1 electron pair. This is nitrogen. This nitrogen. So therefore 1, 2, 3, 4, 5. 5 donor atoms. So nitrogen, 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 nitrogen. So these are the donor atoms. These are what? Donor atoms. How many donor atoms now? 5 donor atoms. And this is the neutral ligand now. So because it is the neutral ligand, because is there any charge now? No charge on the ligand species. And then pentadentate negative ligand. Pentadentate negative ligand. So pentadentate negative ligand. So pentadentate negative ligand means, for example, this is the NH CH2 COO minus. This is the CH2 COO minus. And this is the CH2. This is the CH2 N CH2 COO minus. And this is the attaching to what now? Hydrogen. So one is the donor site now. So this is the donor site. And this is also another donor site. So this nitrogen is having what now? 1 electron pair acting as what now? Donor site. 1, 2, 3. This is the 4th one. And this is the 5th one. So how many donor sites in this pentadentate now? There are 5 donor atoms. 1, 2, 3, 4, 5. So this is what now? This is pentadentate negative ligand. Pentadentate negative ligand. So what is the name of this one now? This is ethylene. This is what now? This is ethylene. So therefore ethylene, 2 nitrogen, therefore ethylene diamino. Ethylene diamino. So how many acetate groups now? This is the acetate. This is what now? This is also acetate. And this is also acetate. So there are 3 acetates ethylene diamino triacetate. Ethylene diamino triacetate. How many negative charges na? 3 negative charges. Therefore, ethylene diamino triacetate. So, ethylene diamino EDTA. So, this is what na? EDTA. EDTA minus 3. So, ethylene diamino triacetate. The abbreviation used in the complex compound, it is the EDTA minus 3 now. So, but it is what now? One hydrogen is therefore this is what now? HEDTA minus 3. HEDTA minus 3. Abbreviation used in the complex compound, it is the HEDTA. So, this is the abbreviation. This is the abbreviation used in the complex. Used in the complex during the nomenclature of the complex compound. HEDTA. So, the charge on this, it is what now? Minus 3 is the charge. So, charge is what now? Minus 3 of this ligand. So, it is belonging to what now? Pentadentate negative ligand. And after this pentadentate, what now? Hexadentate ligands. Hexadentate ligands. So, hexadentate ligands means same. This is the NCH2 C double bond O minus. This is CH2 C double bond O minus, and this is attaching to ethylene group CH2 again N CH2 COO minus, and this is the CH2 C double bond O minus. This is what now? This is the hexadentate ligand, because how many donor atoms now? This is the one donor atom. This is the another one donor atom. This is the lone pair on nitrogen acting as what? Donor site. This is the donor site because of lone pair electron on nitrogen, and this is electron rich because of negative charge acting as donor site. So, similarly this oxygen also donor site now. So, 1, 2, 3, 4, 5, 6. Therefore, this is what now? EDTA minus 4. EDTA minus 4, and abbreviation used in the complexity is the EDTA. Charge is what na? Minus 4 is the charge. Donor atoms are what na? Donor atoms, what are the donor atoms in this case? So, donor atoms are 1 oxygen, 2 oxygen, 3 oxygen, 4 oxygens. So, oxygen and 2 nitrogens. So, these are the donor atoms now. So, this is comes under hexadentate negative ligand. This is the negative ligand, hexadentate negative ligand. So, these are the ligands. These are what? Ligands. So, after this ligands, now we are going to discuss about what now? That is the oxidation number now. So, what is mean by oxidation number? So, what is mean by oxidation number? So, oxidation number, what is the purpose of this oxidation number? So, while naming in the complex compounds, so in the complex compound IUPAC nomenclature, we requires oxidation number of the central atom. Therefore, in order to naming the complex compound, first you have to know what is oxidation number now. So, what is meant by oxidation number? For example, suppose you take the CO NH3 taken twice, taken 6 times and plus 3, or this can also be CO NH3 taken 6 times and Cl3. So, what will be the oxidation number of the central atom now? So, this is the CO is the central atom, here also CO is the central, both are same now. So, what is oxidation number? So, oxidation number is defined as what now? It is defined as the charge carrying by the central metal atom. So, oxidation number is defined as the charge carrying the metal atom, charge carrying the metal atom when all ligands are removing with its electron pair. With its electron pair. With its electron pairs. So oxidation number is the charge carrying the metal atom when all ligands are removing with its electron pairs. For example, by removing all its electron pairs. So this CO is getting what now? Plus 3 charge now. So here also by removing 6 NH3 and 3 Cl. So the NH3 is the ligand and Cl is also another ligand. So actually what is meant by oxidation number? Oxidation number is the charge present on the central atom when all ligands are removing with its electron pairs. For example, oxidation number of the following complex compounds, for example K3FeCN6. So central atom is the iron, therefore you consider this as what now? X. So 3 potassiums are there, therefore plus 3 is the, each potassium is the plus 1 and there are 3 plus 3 and you consider iron is the X and there are this is the Cn minus. So each Cn is the minus 1 into 6 is the minus 1 into 6. It is equal to 0. Sum of oxidation numbers of all the elements in a complex compound should be equal to 0. Therefore what now? This is plus 3 plus X minus 6 equal to 0. From this X is equal to what now? Plus 3 is the oxidation number. Suppose if you take Cu NH3 taken 4 times plus 2. So sum of oxidation numbers of all the atoms must be equal to what now? Plus 2. Charge present on the complex. This is the complex cation. This is the simple neutral this is the neutral compound K3FeCN6. Is there any charge on this one? No charge. So Cu NH3 taken 4 square bracket plus 2. So you consider this as what now? X. So X plus 4, because these are 4. There are 4 ligands there. Therefore 4 into NH3 is the neutral ligand. Therefore its charge is 0. So it is equal to what now? Plus 2. Therefore X becomes what now? Plus 2 is the oxidation number of the copper. So copper oxidation number is the plus 2. So this copper oxidation number is what now? Plus 2 in this case now. Suppose AgNH3 taken twice Cl. So you calculate the oxidation number of the silver. So silver oxidation number, you consider silver is what now? X. So X plus what now? NH3 is the neutral ligand. So we already discussed about the nature of the ligands. This is the neutral ligand, therefore 2 into 0, but Cl is the negative ligand, therefore minus 1 equal to 0. So sum of oxidation numbers of all the elements must be equal to 0. Therefore X is equal to what now? In this case plus 1 is the oxidation number. Suppose CO NH3 taken 6 times and Cl3. So CO is the central atom. Its oxidation number you consider this as X and there are 6 NH3 ligand, therefore 6 into 0, because NH3 is the neutral ligand and Cl is the negative ligand. There are 3 negative ligands, therefore it should be minus 3 is equal to what now? Sum of oxidation numbers of all the elements must be equal to 0. Therefore X is equal to what now? In this case plus 3 is the oxidation number. Suppose CO En taken twice Cl2 and this is Cl. CO En to Cl2 square bracket Cl. So this is a complex compound. So in order to calculate oxidation number of the CO, so you consider this as what now? X. But how many? This is En is the ethylene diamine, which is neutral in nature, therefore 0 into 2. So 2 into 0 and Cl is the minus 1 how many minus 1s now? These are minus 2 and this is also minus 1. Therefore, totally minus 3 is equal to 0. Therefore, x is equal to what now? Plus 3. Suppose COEN taken thrice plus 3. So, what is the oxidation number of this CO? So, CO is the X. You consider this as X. En is what now? This is neutral ligand. So, neutral ligands 3 into 0. 3 into 0 is 0. It is equal to what now? Charge present over the complex plus 3. Therefore, X equal to what now? Plus 3. So, this is the way to calculate the oxidation numbers of the complex oxidation numbers of the central atoms in the complex compound formations. So, K3FeCN6. So, this is the ionic sphere. This is the what now? This is the cationic sphere. In the cationic sphere, we have the one K plus ion. That K plus ions are how many now? 3. So, each K is belonging to what now? Plus 1, because it is first year group element. So, plus 1. And this is you consider this as what? X. And each Cn, there are 6 Cn minus ions. Each one it is minus 1 into 6. Now you add all these. Sum of oxidation numbers of all the elements must be equal to 0 during determination of the oxidation numbers of the central atoms. So, you will getting what now? Plus 3. So, this is the way to calculate the oxidation numbers. So, after this we have the one more topic, that is the coordination number. So, what is meant by coordination number? So, already we learned about this coordination number. Coordination number is the number of chemical bonds. Number of chemical bonds means day 2 bonds are coordinate covalent bonds. Number of chemical bonds are coordinate covalent bonds between the central atom and donor atoms of all the ligands in the coordination sphere. So, this is the coordination number. So, what is coordination number now? It is equal to what now? Number of chemical bonds between the central atom and donor atoms of all the ligands. Number of chemical bonds between the central atom and donor atoms of all the ligands. So, this is the coordination number. For example, let us see in the Cu NH3 taken 4 plus 2. So, how many bonds between the copper and the surrounding ligands? 4 ligands. Now, there are what now? This is the central atom and this is the coordinate covalent bond between the central atom and NH3, one NH3. This is the second one and this is the third one and this is the fourth one. Therefore, how many chemical bonds between the copper central atom and 4 NH3 ligands? There are 4 day 2 bonds. 4 day 2 bonds between the, this is the one day 2 bond, this is another day 2 bond, this is another third one, this is the fourth one. There are 4 day 2 bonds between the central atom and donor atoms of amine ligand. Therefore, coordination number in this case it is 4. Suppose Ag NH3 taken twice Cl. So, what will the coordination number? So, the number of chemical bonds between the silver and the 2 NH3 ligands. Silver is the central atom and NH3 is the ligand. How many ligands there now? 2 ligands there. Therefore, in between the one central atom and 2 NH3s, there are 2 chemical bonds. There are 2 coordinate covalent bonds exist between the central atom and 2 NH3 ligands. Therefore, coordination number is equal to 2 only. Suppose CO NH3 taken 6 Cl3. There are how many covalent coordinate covalent bonds between the NH3 and CO. There are 6 coordinate covalent bonds. Therefore, coordination number is equal to 6. Suppose COEN taken twice Cl3, but how many? But here this is the monodentate, it is also monodentate, it is also monodentate. So in case of monodentate ligands, coordination number is equal to number of monodentate ligands, and its denticity. So here there are 6 monodentate ligands, and their denticity, there are 6 monodentate ligands. Each monodentate ligand denticity is only 1. Therefore, 6 into 1, it is the coordination number of this complex compound. But here this is the bidentate ligand. So each bidentate ligand is donating 2 electron pairs to the central atom by forming what? 2 coordinate covalent bonds. Therefore, each bidentate is forming 2. Therefore, number of bidentate ligands 3 into its 2. Number of donor atoms are 2. Therefore, coordination number is equal to 6. So the formula of this one, it is coordination number. If only monodentate ligands, if only monodentate ligands present in the complex, coordination number is equals to what? Number of monodentate ligands into 1. This is the denticity of the monodentate ligand, is the 1. Suppose if only bidentate ligands, if only bidentate ligands are present in the complex, coordination number is equal to number of bidentate into its denticity, bidentate ligands, and denticity is what? 2. So if only bidentate ligands are present in the complex compound, how can we calculate the coordination number? Coordination number is equal to number of bidentate ligands into 2. So here number of bidentate ligands 3. 3 into 2 is the 6. Therefore, coordination number is 6. If both monodentate and bidentate ligands are present, then coordination number is equal to number of bidentate into 2, number of bidentate ligands into 2 plus number of monodentate ligands into 1. So these are the formulas used to calculate coordination number. So if only what now, this one, this is the, if only monodentate ligands are given in the complex, you go through coordination number is equal to number of monodentate ligands into 1 only. If only bidentate ligands are present in the complex, coordination number is equal to number of bidentate ligands into 2 is the formula. If both monodentate ligands and bidentate ligands are given in the complex compound, then you go through to calculate coordination number equal to number of bidentate ligands into 2 plus number of monodentate ligands into 1. So this is the way to calculate what na coordination number. Suppose COEN taken twice Cl2 Cl. So this is the complex compound. This complex compound is having both bidentate ligand and monodentate ligand. So En is a bidentate ligand, Cl is a monodentate ligand. So for this coordination number is equal to what now? Bidentate ligands are how many now? 2 bidentate ligands. Each bidentate ligand is donating two electron pairs. Therefore density is 2. So 2 into 2 plus monodentate ligands are 2. 2 into 1. So therefore 2 into 2 4. 4 plus 2 is 6. So coordination number is equal to 6 for this COEN taken twice, Cl2 square bracket Cl. So this is the coordination number of the 2 into 2 plus 2 into 1, it is equal to 6. So this is the coordination number. So now we are going to discuss types of coordination spheres. Types of coordination spheres. Coordination spheres. So what are the types of coordination spheres? So depending upon the number of metal atoms present in the coordination sphere, mononuclear and polynuclear spheres. There are two different types of based on the number of metal atoms in the coordination sphere. In the coordination sphere, there are two types of coordination spheres. Two types of coordination spheres. One is mononuclear and another is the polynuclear. One is mononuclear coordination sphere. Mononuclear coordination spheres means mononuclear complex compounds. And second, it is the binuclear or polynuclear coordination spheres. Polynuclear coordination spheres or polynuclear complexes. For example, so what are mononuclear coordination spheres? If only one metal atom is present. If only one metal atom is present in the complex, such type of species are called as what now? Mononuclear coordination spheres or mononuclear complex compounds. For example, FeCO taken 5. This is the one complex compound in which how many metal atoms there now? Only one metal atom is there. Therefore, this is the mononuclear. And suppose AgNH3 taken twice square bracket plus, and CuNH3 taken 4 square bracket plus 2. And all these compounds having what now? How many metal atoms? Only one metal atom. If only one metal atom is present in the complex, then such type of compounds are what now? Mononuclear coordination spheres. Mononuclear coordination spheres. If more than one metal atom is present, so such type of compounds, coordination spheres are what now? They are called as what? Polynuclear coordination spheres. So these polynuclear coordination spheres again dividing into two different types: homopolynuclear, and heteropolynuclear. For example, CO2, CO8. So in this particular compound, we have two cobalt metal atoms. Both are same, CO. Homopolynuclear means if two metal atoms are same, if more than one metal atom is present, what now? That is polynuclear. But here there are two metal atoms, both are same, therefore they are under what na homo polynuclear, CO2 CO8, CO2 CO8, and this is Fe3 CO12, Fe3 CO12. So this polynuclear compound is having more than one metal atom. There are how many metal atoms in this? 3 iron atoms there in this. In this there are 2 metal atoms, cobalts, and Mn2CO10. Mn2CO10. So they are in this we have what same 2 manganese atoms. In this there are 3 same iron atoms. In this there are same cobalt atoms. Therefore they all are under homo polynuclear compounds. And another it is the hetero-polynuclear compounds. Hetero-polynuclear compound means, suppose this is the Fe and Mn2, CO is the 14. Fe, Mn2, CO 14. In this particular compound we have different metal atoms. One is iron, 2 manganese atoms. Fe, Mn2, CO. CO is the ligand. How many ligands there now? 14 ligands there. This is the complex compound having more than one metal atom. Therefore, it is belonging to what? Polynuclear coordination sphere, under in which it is hetero-polynuclear compound because metal atoms are different. One is iron, 2 are manganese atoms. This is the hetero-polynuclear. These are under what? Homo polynuclear. CO2 CO8, Fe2 Fe3 CO12, Mn2 CO10, Mn2 CO10. So these are what polynuclear coordination spheres. What are coordination sphere? Generally based on the number of metal atoms in the coordination sphere. In the square bracket region, if only one metal atom is present, then the type of it is what mononuclear. If it is more than one metal atom is present, they are what polynuclear coordination spheres. If polynuclear coordination spheres with more than one same metal atoms, what homo polynuclear. If they are having what 2 different metal atoms, then such type of nuclear compounds are what hetero-polynuclear compounds. And then we have the another one type of complexes, that is homoleptic and heteroleptic. What are homoleptic compounds? Homoleptic and heteroleptic compounds. Heteroleptic compounds are coordination spheres. Homoleptic, heteroleptic compounds are homoleptic, heteroleptic coordination spheres. There are 2 different, these are what coordination spheres. Coordination spheres. So what is meant by homo? Homo means same. For example, a complex compound with same type of ligands. Homoleptic. Homoleptic coordination spheres. Coordination spheres. If complex compound having same type of ligand, if complex compound having a same type of ligands, similar ligands, same type of ligands means similar ligands, they are what homoleptic coordination spheres. For example, CONH3 taken 6 times plus 3. So in this particular compound there are 6 NH3 ligands, all are similar ligands. Therefore this is what homoleptic coordination sphere or homoleptic complex compound. So CO is bonding with what 6 NH3 ligands. So NH3, 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 NH3. So all these are what similar ligands. Therefore it is homoleptic ligand, homoleptic compound. One more example, COCl6 minus 3. COCl6 minus 3. So in this also there are what type of ligands na? Similar ligands. All ligands are similar. They are what na? Cl. In this all the ligands are NH3 ligands. All the 6 ligands are belonging to same. In this all the 6 ligands are belonging to the same Cl. Therefore it is also what na? Homoleptic. This is homoleptic. It is also homoleptic. But what about the heteroleptic? So heteroleptic means different. Heteroleptic coordination pairs are compounds. Coordination pairs. Heteroleptic coordination pairs are complexes. So what they are now? For example, CO, En taken to Cl, Br and Cl. So what it is? This is CO, En to Cl, Br, Cl. So in the coordination pair there are 3 different types of ligands. One is the En and another is the Cl and another is the Br. So all the ligands are different. En is different, Cl is different, Br is different. So ligands are different in this case. If complex compound having a different type of ligands in the coordination pair, they are what now? Heteroleptic coordination pairs. So these are the different ligands, different types of ligands, different, not same, different type of ligands. Different type of ligands. Therefore this compound, it is what now? Heteroleptic compounds. Heteroleptic coordination pairs are heteroleptic complex compounds. So this is the homoleptic heteroleptic compounds. One more example for the heteroleptic. Suppose CO, En, Cl2, Br2. CO, Cl2, Br2. So what is the oxidation number? X minus 4 is equal to minus 1. X minus 4 is equal to this En, it is the neutral ligand, Cl is the minus 1, minus 1 into 2 minus 2, this is minus 1 into 2 minus 2, therefore totally minus 4, it is equal to minus 1. What will be the oxidation number of this CO? CO, it is equal to minus 1 plus 4, minus 1 plus 4. So it is minus 1, this 4, therefore X is equal to what? Plus 3 or not? So therefore you should write on the sphere minus 1. So here also this En is different, this Cl is different, this Br is different now. Therefore it is also what now? Heteroleptic compounds. So once again, what are homoleptic, what are heteroleptic? Homoleptic means complex compounds having same type of ligands, similar ligands in the coordination pair. Here different ligands in the coordination pair. So they are what now? Heteroleptic coordination pairs. So now, so students, if you have any doubt, you ask on the scroll number.
స్టూడెంట్స్ కి ఎటువంటి డౌట్స్ ఉన్నా సో చాట్ బాక్స్ లో చాలా మంది కొత్తగా టైం పాస్ స్టార్ట్ చేస్తున్నారు, క్లాస్ వినట్లేదు. రవికుమార్, రాహుల్, తేజ ఇట్లా చాలా మంది ఉన్నారు. రెస్పెక్టెడ్ టీచర్స్, దయచేసి ఫోన్ తీసుకున్నారు పిల్లలు చూస్తున్నారా లేకపోతే క్లాస్లో ఎట్లా వింటున్నారో తెలియదు, కానీ వాళ్ళు చాటింగ్ మాత్రమే చేస్తున్నారు చాట్ బాక్స్లో. సో అంకిత్ నాయక్ అని చాలా మంది ఉన్నారు. సో రెస్పెక్టెడ్ టీచర్స్ వాళ్ళందరూ కూడా ఒకసారి పిల్లలు మరి క్లాస్లో వింటున్నారా, జస్ట్ చాట్ చేస్తున్నారా, తమాషాలు చేస్తున్నారా చూడండి. అదేవిధంగా ఎవరికైనా డౌట్ ఉంటే, ఇప్పటి వరకు జరిగిన క్లాస్లో ఎవరికైనా డౌట్ ఉంటే మీ స్క్రీన్ పైన ఒక నంబర్ స్క్రోల్ అవుతుంది. సో ఆ నంబర్కి కాల్ చేసి అడగడం వల్ల మీ డౌట్స్ని క్లారిఫై చేస్తారు. టైంపాస్ చాలామంది చాట్లో టైంపాస్ చేస్తున్నారు. సో అది మీరే క్లాసు మిస్ అవుతారు. సో దయచేసి అట్లాంటివి చేయకండి. ఎవరికి విద్యార్థులకి ఎవరికైనా డౌట్ ఉంటే దయచేసి మీకు ఇప్పటి నుంచి ఒక 20 minutes మీకు టైం ఇవ్వబడుతుంది. మీకు జరిగిన టాపిక్లో మీకు ఎటువంటి డౌట్స్ ఉన్నా కానీ మీ స్క్రీన్ పైన ఒక నంబర్ స్క్రోల్ అవుతుంది, ఆ నంబర్కి కాల్ చేస్తే సార్ మీకు డౌట్స్ క్లారిఫై చేస్తాడు. సో యా, రాహుల్ డౌట్ ఉందన్నారు. సో దయచేసి మీ స్క్రీన్ పైన ఒక నంబర్ స్క్రోల్ అవుతుంది, ఆ నంబర్కి కాల్ చేయండి. సో అదేవిధంగా మీరు అడిగినప్పుడు సార్కి వాయిస్ మీకు రిసీవ్ కావడానికి దాదాపు ఒక 10 సెకండ్స్ గ్యాప్ ఉంటుంది. సో ఆ గ్యాప్ని మీరు చూసుకోండి.
హలో
హలో, చెప్పండి.
గుడ్ ఆఫ్టర్నూన్ సార్. ఓకే సార్. సార్ మోనోడెంటేట్ నెగిటివ్ లైగాన్స్ లో ఎగ్జాంపుల్స్ చెప్పారు సార్.
This is the monodentate negative ligands, madam. So ligands, monodentate means ligands which have one donor site. For example, you take the amido. So in the amido we have what now? This is nitrogen. On nitrogen we have one lone pair, even though it has what now? One negative charge. So this nitrogen is nitrogen with negative charge. Excess electrons there now.
మీరు క్వశ్చన్ అడిగే వాళ్ళు దయచేసి మీ స్క్రీన్కి దూరంగా, మీ స్పీకర్లకి దూరంగా బయటికి వచ్చి అడగండి. మీరు అక్కడనే ఉండి క్వశ్చన్ అడగడం వల్ల అక్కడున్న సౌండ్ రీసౌండ్ వచ్చి ఎకో వచ్చి అందరికీ డిస్టర్బెన్స్ అవుతుంది.
So monodentate negative ligands means ligands having what na one donor site. The donor site is with negative charge. Monodentate negative. So this NH2 minus is having what negative charge, and in that what na nitrogen is the donor atom.
So nitride has minus three charges, sir.
Nitride, amido, imido, nitrido. Nitrido means nitrido means N minus 3. In that nitrogen is the donor site. In azido, hydrozoic acid. N3H is the hydrozoic acid. N3 minus is the N3
Charge is minus 3, sir.
So N3 minus what?
Sir, N minus 3 in charge we have to write minus 3, no, sir.
So N minus 3 means the nitrido. Nitrido means N minus 3. So N minus 3 is the monodentate negative. In that monodentate negative we have the 3 negative charges. 3 negative, all these.
Okay, sir.
So these are the negative ligands only. So charge is what now? Minus 3 only. So on nitrogen we have the minus 3 charge, but with 1 minus 1 only it is donating.
Okay, sir. Thank you, sir.
For example, OH minus na. Okay.
Okay, sir. Hello. 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 Hello.
వెయిట్ చేయండి
Hello. 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 Hello, sir. Hello, sir.
దయచేసి మీరు స్పీకర్ బయటికి రండి. స్పీకర్ ఉన్న కాడ ఉండకండి. మీరు స్పీకర్ బయటికి రండి. స్పీకర్లు ఉన్న కాడ మాట్లాడితే అది రీసౌండ్ వచ్చి మళ్ళీ డబుల్ టైం వినబడుతుంది. అదే అండి, మీరు స్పీకర్ బయటికి వచ్చి మాట్లాడండి.
హలో సార్. హోమోలెప్టిక్ హెటరోలెప్టిక్ డిఫరెన్స్ చెప్పండి సార్. హోమోలెప్టిక్ హెటరోలెప్టిక్ డిఫరెన్స్ చెప్పండి.
So homoleptic coordination compounds. Homoleptic means complex compound having same type of ligands or similar ligands present in the coordination sphere. So this is the square bracket. This square bracket is the okay. So homoleptic means this is the coordination sphere. In this coordination sphere, there are all 6 NH3 ligands are similar. But in the square bracket of the heteroleptic, different ligands present in this. So 2 EN ligands, one is CL ligand, another is the BR ligand. This is the coordination sphere. So here different ligands in the sphere. There are same ligands in the homo. Homo means same.
Sir, coordination number difference. Coordination number differences. Coordination number differences.
Coordination number means coordination number means this is the central atom. Okay. So coordination number means number of chemical bonds between the central atom and donor atoms of all the ligands. Number of chemical bonds between the central atom and donor atoms of all the ligands in the coordination sphere. Okay students, I hope you understand well. So in the next class we will meet you.